Welcome to the QUASARIA channel. Today I will tell you an incredible detective story about how humanity learned to track down the most mysterious and dangerous predators of the universe. Supermassive black holes hiding at the edge of the observable cosmos. Imagine, you are a detective, but your opponent is invisible, does not make sounds, and absorbs even light. How to find something that by definition cannot be seen. That was the challenge astronomers faced at the end of the 20th century. And their main weapon was a space telescope named after the great physicist Chandra. On July 23, 1999, the Space Shuttle Columbia carried this incredible hunter into orbit. Chandra is no ordinary telescope. He sees X-rays, the same energy that matter emits at the moment of its death, falling into a black hole. If the black hole is the killer, then Chandra sees the death scream of its victims. The first high-profile hunt began almost immediately. Astronomers pointed Chandra at a patch of sky no larger than the head of a pin, stretched out at arm's length. It was a gamble to waste the telescope's precious time on the void. But when Chandra opened his eyes, the scientists froze. Where there was nothing in visible light, the X-ray sky burned with hundreds of dots. Black holes. Dozens, hundreds of black holes, each with a mass of millions of suns, devouring entire galaxies billions of light years away. One of these points was particularly interesting to the team. The object received a boring name, QUASARIA 123647.9 plus 621251. Behind this code was a black hole, the light from which traveled to us for more than 12 billion years. When this light set off, our solar system did not yet exist. There was no land. It was a voice from the infancy of the universe. But how did scientists know that this was a black hole and not just a hot star or a supernova explosion? This is where the real detective work begins. Chandra doesn't just capture light, he analyzes its signature. Each element falling into the black hole screams at its own frequency. Iron screams differently from oxygen. Hydrogen is not like carbon. Chandra hears these screams and paints a picture of the crime. This distant black hole had a strange handwriting. It devoured matter at an incredible rate, thousands of solar masses every year. The gas, accelerated to the speed of light, swirled around the event horizon and emitted as much energy as 1 trillion stars like our sun. It was a real cosmic monster in its heyday, when black holes grew faster than at any time in the history of the universe. But the most amazing discovery was yet to come. In 2011, Chandra detected something impossible, a black hole that existed just 770 million years after the Big Bang. An object in the constellation Canes Venatici, cataloged as a quasar with a redshift of 6.3. This black hole weighed 2 billion times the mass of the Sun. 2 billion, when the universe was less than 6% of its current age. Imagine a forensic scientist who finds the corpse of an adult in a maternity hospital. Astronomers experienced approximately such a shock. According to all theories, black holes grow slowly, gradually, devouring matter over billions of years. But this one grew too fast, too big. It's too early. It was like finding traces of an ancient crime that changes everything we thought about the early universe. Chandra continued to dig deeper. A deep survey of Chandra in a region of the sky, known as the Hubble field, has revealed more than 500 supermassive black holes. Each is the center of a distant galaxy. Each told her own story. Some were active, furiously devouring everything around them. Others slumbered, having had their fill billions of years ago. Still others were just waking up, starting their feast. One of the most dramatic stories unfolded in the galaxy cluster MS 073 5.6 plus 7421. Chandra saw giant bubbles of hot gas there, each hundreds of thousands of light years across. These bubbles are scars from an ancient explosion. The supermassive black hole at the center of the cluster once ejected jets of matter accelerated to near light speed. These jets punched holes in the surrounding gas like bullets through water. The energy of this ejection was so monstrous that it would have been enough to power the entire human civilization for a time 1,000,000 billion times the age of the universe. But the most disturbing discovery Chandra made closer to home. At the center of our own galaxy, the Milky Way, sleeps a black hole with a mass of 4 million suns. Her name is Sagittarius A-. Chandra had been observing it for years, recording periodic flares. Sometimes Sagittarius A wakes up and eats something, a comet, a cloud of gas, maybe an unlucky star. And then our quiet galactic center flashes with X-rays. Chandra once recorded a flash that was 400 times brighter than usual. Something big fell into our black hole. We do not know what exactly, but it's a reminder. The monster in the center of our house isn't dead. He's just sleeping. And someday, perhaps millions of years from now, when our galaxy collides with the Andromeda Galaxy, it may wake up for real. Chandra has also uncovered one of the darkest secrets of black holes: their ability to kill galaxies. In the galaxy NGC 1277, the telescope discovered a black hole with a mass of 17 billion solar masses, almost 14% of the mass of the entire galaxy. For comparison, in normal galaxies, the black hole is less than 1%. This black hole is so large that it has sucked almost all the gas out of its galaxy. NGC 1277 is dead. New stars are not born in it. This is a ghost galaxy killed by its own center. Each observation of Chandra is a glimpse into the past. The farther we look, the younger the universe we see, and the picture that Chandra paints turns our ideas upside down. It turns out that black holes are not just space junk, the end point of the evolution of massive stars. They are the architects of the universe. They control the birth of galaxies. They regulate how many stars can be born. They determine the fate of entire clusters of galaxies. In the Perseus cluster, Chandra found ripples on the surface of hot gas, sound waves from the black hole that sound on a note that is 57 octaves below the mean to the Perseus cluster. It is the lowest sound ever detected in the universe. The black hole is singing, and its song has been going on for 2.5 billion years. But the hunt continues. Every year, Chandra finds new clues. In 2019, it detected signs of medium-sized black holes, an elusive intermediate between stellar black holes and supermassive monsters. In 2020, he recorded a black hole ejected from its galaxy after colliding with another black hole, an exile hurtling through the intergalactic void at a speed of thousands of kilometers per second. As I tell you this story, Chandra is still out there in orbit, still hunting. His eyes are open. He looks into the abyss, and the abyss looks back. For 25 years of work, he made more than 23,000 observations. He found traces of thousands of black holes, changed our understanding of space. But the most important thing he showed us is that we live in a universe where invisible predators form the structure of reality, where the darkest objects create the brightest light, where the death of matter generates energy visible through half of the cosmos, where each galaxy carries darkness at its heart, which is both its creator and potential killer. One of Chandra's most eerie finds is what scientists have dubbed the echo of a light ghost. In 2013, the telescope recorded a strange phenomenon in the clouds of gas around the center of the Milky Way. These clouds glowed with X-ray light, but there was no source of radiation. It was like hearing the echo of a scream when the screamer was gone. Astronomers realized that they were seeing reflected light from a flare that occurred hundreds of years ago. Our own black hole, Sagittarius A-, then experienced a period of activity thousands of times more powerful than it does now. It was devouring something massive, and the light from this feast still travels through the galaxy, reflecting off the interstellar clouds like a ghost of the past. This means that if people had lived in those times, they would have seen a completely different sky. The center of the galaxy would shine brighter than the full moon, pulsing with an ominous light. An invisible predator announced its presence. But Chandra doesn't just look into the past. He helps predict the future. In the galaxy NGC 6240, the telescope discovered two supermassive black holes orbiting each other just 3,000 light-years away. This is the dance of death. In a few tens of millions of years, they will collide and merge, creating an even more massive monster. At the moment of merging, they will spew out so many gravitational waves that space-time will vibrate like the surface of a pond after a thrown rock. These waves will reach Earth, and our detectors will record the last cry of the two dying giants. Chandra has shown that such clashes are not uncommon. In the universe, there's a ruthless game of billiards on a galactic scale. Galaxies collide. Their black holes find each other, like two predators in the same territory. And there's only one winner left, the one who is greater. In the cluster Abell 2142, Chandra witnessed a cosmic catastrophe in real time. Well, as real as possible for events that have been beaming toward us for 1 billion years. Two giant clusters of galaxies collide. Each has its own supermassive black hole. The gas between the clusters is heated to a temperature of hundreds of millions of degrees. Chandra sees a shock wave, a boundary where two oceans of incandescent plasma collide at thousands of kilometers per second. This collision releases energy equivalent to the explosion of billions of supernovae. When astronomers first saw this data, they couldn't believe it. The numbers seemed impossible. But Chandra is not wrong. Its detectors capture every photon of X-rays with absolute precision. And the picture was clear. We were witnessing one of the most energetic events in the universe after the Big Bang. Chandra's findings in the area of the so-called darkened quasars turned out to be especially ominous. These are black holes hidden behind thick clouds of dust and gas. Invisible light, they are not visible, they are camouflaged. But X-rays pierce this veil, and Chandra brings the predators out into the open. It turned out that there are many more such hidden monsters than scientists thought. Some estimates suggest that we have seen only half of all active black holes in the universe. The rest are hiding, invisible, but still deadly. In 2015, Chandra helped solve one of the strangest mysteries of all, a disappearing black hole. The object in the galaxy N6946, BH1, simply disappeared. A star with a mass of 25 suns suddenly dimmed, emitted a faint flash of infrared radiation, and disappeared. No supernova explosion, no remains. Chandra confirmed that the star now has an X-ray source characteristic of a black hole. The star did not explode. She's just collapsed swallowing itself so quickly that not even the explosion had time to break out. A quiet death. The birth of a black hole without fanfare. This discovery has revolutionized the understanding of how black holes form. It turns out that some massive stars die not in the glory of the explosion, but in the silence of collapse. They disappear from a universe like criminals erasing their tracks. Chandra also discovered what scientists have called galaxy killers, jets of matter erupting from black holes at close to the speed of light. These jets pierce through the galaxy, escaping into intergalactic space at a distance of hundreds of thousands of light years. They heat up the gas so much that it can no longer cool down and form new stars. The galaxy is sterilized. Her future is killed by her own center. In the Centaurus A galaxy, Chandra has tracked such a jet for 1,000,000 light years. It is the longest structure created by a single object ever discovered in the universe. The black hole at the center of Centauri shoots like a sniper, aiming at the very structure of space. And it has been shooting for millions of years without a break. But perhaps Chandra's most disturbing discovery concerns the fate of our own galaxy. As I mentioned, in a few billion years, the Milky Way will collide with Andromeda. Chandra's observations of other merging galaxies reveal what will happen next. Two black holes, ours and Andromeda's, will begin to approach each other. At first, they will be thousands of light years apart, slowly swirling in a gravitational dance. Then hundreds of light years, dozen, and finally, in the last moments before the collision, they will orbit each other thousands of times per second, accelerating to unimaginable speeds, emitting gravitational waves of unimaginable power. The merger will release energy equivalent to converting the mass of several suns into pure energy in a fraction of a second. The new, merged black hole will weigh about 8 million solar masses and will be one of the most massive objects in the local group of galaxies. And around it, in the chaos of a gravitational cataclysm, millions of new stars will be born from the gas compressed by the shock waves of the collision. Chandra has seen this process in dozens of other galaxies. He knows what awaits us. This is not the end of the world. This is a transformation, a cosmic rebirth through a catastrophe. In a quarter century of hunting, Chandra has taught us a crucial lesson. Black holes are not just graves of matter. They are alive in a metaphorical sense. They grow, feed, sometimes hibernate, sometimes wake up hungry. They interact with their surroundings in complex ways. They form galaxies like a sculptor shapes clay. They kill some stars and provoke the birth of others. They are the architects of the cosmos, the engineers of the evolution of the universe. And the most surprising thing is that without them, we would not exist. Studies using Chandra's data have shown that black holes at the centers of galaxies control the rate of star formation. A black hole that is too active means that the galaxy dies too quickly. Too calm, the galaxy produces stars chaotically and unstable. Our Milky Way is in perfect balance. Our black hole is calm enough to allow the formation of the solar system, the birth of the Earth, the emergence of life, and evolve over 4 billion years without catastrophic bursts of radiation that would sterilize all life. We exist because the monster at the center of our galaxy is asleep. But his sleep is not eternal. Chandra recorded another eerie detail about the nature of these predators. They leave scars that do not heal for billions of years. In the Hercules 8 galaxy, the telescope found giant cavities in the hot gas surrounding the galaxy. These voids were blown away by black hole jets more than 100 million years ago, but they're still there like fossilized dinosaur footprints. The structure of these cavities is so complex that astronomers can read the history of black hole activity in them, just as archaeologists read the layers of the Earth. It turned out that the black hole in Hercules, it did not just eject jets once and calm down. She did it cyclically. She woke up, ate, spewed energy, fell asleep, woke up again. Each cycle left its own mark. And these marks tell the story of the galaxy over hundreds of millions of years. Chandra has become not just a black hole hunter, but an archaeologist of the cosmos, reading ancient records written in light and shadow. One of Chandra's most dramatic observations has occurred in real time. Just how real an event billions of light years away can be. In 2014, the telescope captured the moment when a black hole in the galaxy PGC 043234 began to tear the star apart. This event, known as tidal disruption, happens when a star gets too close to the event horizon. The gravity of a black hole is so strong that its attraction to the near side of the star is much greater than to the far side. The star is literally stretched like chewing gum. It turns into a long filament of incandescent gas, half of which falls into the black hole, and half of which is ejected into space. Chandra observed how the brightness of this event changed over the months. At first, the flare was weak. The first portions of stellar material reached the black hole. Then the brightness exploded. The bulk of the star began to fall inward. Then a slow decline that stretched over years as the last remnants of the star swirled in the accretion disk, heated to millions of degrees, and emitted a dying X-ray cry. It was like watching a murder in slow motion. A star that may have been shining for billions of years, which could have had its own planets, was destroyed in a few hours. And we, nearly a billion light years away, have seen echoes of her death eons after the crime was committed. But Chandra also found glimmers of hope in the darkness. In some galaxies, black holes paradoxically create life, or at least the conditions for it. In some cases, this compression triggers the collapse of gas clouds and the formation of new stars. A black hole is both a destroyer and a creator. In the Minkowski galaxy, Chandra's object recorded just such a thing. A jet of a black hole collided with a cloud of gas, and young, hot stars flared up at the collision site. The black hole's deadly weapon accidentally lit up new suns. This discovery forced scientists to reconsider the role of black holes in the evolution of the universe. Perhaps the first generations of stars, after the dark ages of space, were triggered by the activity of ancient black holes. Perhaps the entire structure of modern galaxies is the result of a balance between the destructive and creative influence of these objects. Chandra also helped unravel the mystery of so-called wandering black holes. When two galaxies merge, their black holes do not always have time to merge before the merger process is complete. Sometimes one of the black holes receives a gravitational push and is ejected from the center of the new galaxy like a stone from a sling. These exiles wander in the intergalactic void, invisible but still hungry. In 2021, Chandra discovered one such fugitive 230 million light years from Earth. A black hole with a mass of several million suns was hurtling through space at a speed of 1,500 kilometers per second, leaving a trail of hot gas 300,000 light years long. It was a ghost spaceship hurtling to nowhere, feeding on the rare clouds of gas it encountered along the way. Its journey will last billions of years until it finds a new galaxy or is left all alone in the expanding universe. How many of these exiles roam in the darkness between galaxies? Chandra suggests that there may be millions, an army of invisible predators lost in the void. But perhaps Chandra's most philosophically disturbing discovery concerns the future of black holes themselves. In a distant galaxy, a telescope has discovered a black hole that has nearly depleted all available food sources around it. It ate all the nearby stars, all the gas, all the dust. Now she is starving. Its radiation fades away. It becomes darker and colder. In trillions of years, when all the stars in the universe are extinguished, when the last clouds of gas are exhausted, all black holes will be in this state. They will be the only remaining objects in the dead universe. And then their own dying will begin. A slow, unimaginably slow evaporation through Hawking radiation. A process that will take not billions, but googles of years, one with 100 zeros. Chandra showed us a preview of this future. Cold, silent, dying black holes in a cooling universe. The last monuments to an era when space was full of light, life, and energy. But we are not there yet. We live in a golden age of the universe, when stars are burning, galaxies are colliding, and black holes are feasting. And Chandra gives us the opportunity to observe this feast from a safe distance. In 25 years of operation, this telescope has fundamentally changed our picture of the cosmos. Before Chandra, black holes were theoretical exotics, mathematical curiosities in Einstein's equations. After Chandra, they became real, tangible objects that we can study, catalog, and understand. He turned black holes from an abstraction into concrete participants in the cosmic drama. Every night, while you sleep, Chandra continues his hunt. Its detectors pick up photons that have traveled for billions of years through the cosmic void. Each photon is a message from the past, a cry of dying matter, an echo of an ancient catastrophe. And scientists who are awake in observatories around the world are deciphering these messages, reconstructing the stories of crimes committed long before the birth of our planet. The telescope is aging. Its systems have been operating for much longer than their planned service life. Engineers are constantly finding ways to keep it alive by readjusting the orbit, compensating for component failures. But one day, maybe in 5, maybe in 10 years, Chandra will close his eyes forever. Its successor, a next-generation X-ray observatory, may already be in development. But even when Chandra is gone, his legacy will remain. Thousands of discoveries, petabytes of data that scientists will analyze for decades to come, and a fundamentally altered understanding of how our universe works. There's something almost poetic about the way Chandra works. It is named after Subramanian Chandrasekhar, an Indian-American astrophysicist who in the 1930s proved the existence of a mass limit for white dwarfs, a discovery that eventually led to an understanding of how black holes form. Chandrasekhar died in 1995, for years before the launch of the telescope that bears his name. He never saw his legacy grow into the greatest hunter of the very objects whose existence he helped predict. But in a sense, Chandrasekhar sees them now through his namesake's eyes, through every observation, every discovery. Science has this amazing ability. A person can die, but his ideas, his contribution continue to live, develop, and open up new horizons. Among all Chandra's discoveries, there is one that astronomers call the creepiest image of the cosmos. This is an image of the region near the supermassive black hole at the center of the galaxy Messier 87, the same galaxy whose shadow was subsequently photographed by the Event Horizon Telescope. Chandra's image shows a jet erupting from the black hole, but not just any jet. It found knots, bright clumps of radiation moving outward at a speed that seems to exceed the speed of light. Of course, nothing can travel faster than light. It's an illusion of perspective caused by the jet pointing almost directly at us. But the effect is fascinating and frightening at the same time. We see matter accelerated to 99.99% of the speed of light, rushing through space with energy capable of destroying entire star systems. This jet stretches for 5,000 light years. If it were pointed at Earth and we were in its path, life on our planet would have been wiped out long before we knew the threat existed. Radiation would travel at the speed of light. We would not see it approaching. Fortunately, we are safe. But it's a reminder of how fragile our existence is in a space full of such monstrous forces. Chandra also discovered a phenomenon that scientists called galactic cannibalism with particular cruelty. In the galaxy cluster Abell 85, the telescope has recorded a giant elliptical galaxy devouring a smaller spiral galaxy. But the process did not go as expected. Normally, in galactic engulfment, the prey is slowly torn apart by tidal forces, its stars scattering in orbit around the predator over billions of years. Here, however, everything happened differently. The black hole at the center of the large galaxy was activated by the influx of gas from the victim and began to eject jets of such power that they literally tore the smaller galaxy apart in a cosmically instantaneous time, several tens of millions of years. Chandra's X-rays show the wreckage of the prey scattered around the predator, still hot from the violence they were subjected to. It wasn't just a takeover, it was murder. And in 2018, Chandra witnessed an event that astronomers couldn't explain at first. In a galaxy 6 billion light years away, a source of X-rays of unprecedented brightness suddenly erupted. In a few hours, it became brighter than 1 trillion stars. Then, over the following weeks, it began to slowly fade away. The first thought is a supernova, but the nature of the radiation did not coincide. The second is the tidal destruction of the star, but the scale was too large. In the end, the scientists came to a shocking conclusion. They observed the moment when a medium-sized black hole, perhaps several thousand suns, fell into a supermassive black hole weighing billions of solar masses. It was cannibalism among the predators themselves. The larger black hole ate the smaller one, and Chandra recorded the last cry of the victim, a burst of energy at the moment of crossing the event horizon. Imagine, somewhere in the universe, 6 billion years ago, when our Earth was just forming from a protoplanetary disk, two invisible monsters came together in the final battle. The smaller one, with a mass of more than 1,000 suns, doomed, revolved around the larger one faster and faster. In the last moments before the absorption, it experienced gravitational forces capable of tearing apart the neutron star. Its event horizon was deformed, stretched, merged with the predator's event horizon. And then nothing. Silence. Two monsters became one. But before it disappeared, the smaller black hole spilled so much energy into the universe that we were able to pick up an echo of it after half the existence of the cosmos. Chandra showed us that the universe is not the calm, measured place that is sometimes portrayed in textbooks. It is an arena of constant struggle, where gravity, the weakest of the fundamental forces at the quantum level, becomes the absolute tyrant on a cosmic scale. Black holes are gravity in its purest, most concentrated form. They are so massive that they warp the fabric of space-time to the limit, creating vortexes from which nothing can escape. And yet, paradoxically, it is around these objects that the brightest events in the universe take place. Incident matter emits as much light as entire galaxies. Jets that erupt along the spin axis of black holes are visible billions of light years away. Black holes themselves are completely black and invisible, but their presence illuminates the cosmos brighter than anything else. There's a deep metaphor in this. Sometimes it is in the darkest places that the brightest light is born. It is at the edge of the abyss that matter reveals its true energy. Chandra also taught us another important lesson. Almost nothing in the universe happens instantaneously. Even the most catastrophic events unfold over millions of years. Galaxies collide not like cars on a road, but like two clouds of fog slowly passing through each other. Black holes don't swallow stars in a second. The process takes months and years. Even the light from these events travels billions of years before reaching our eyes. We see the universe in slow motion, stretched across time and space. And Chandra is our projector, showing us this slow, majestic, terrifying film about the birth, life, and death of galaxies, stars, and black holes themselves. There is something humble in this knowledge. We, tiny creatures on a small planet near an unremarkable star, have been able to build an instrument capable of seeing the most extreme objects in space. We have deciphered the language of X-rays, learned to read messages written by gravity and plasma. We have turned the invisible into the visible, the unknowable into the known. Chandra is an extension of the human eye, outside the atmosphere, tuned to frequencies that our biology can never perceive directly. Through it, we see what was created by nature to remain forever hidden. We track down invisible monsters and force them to tell their stories. And these stories turn out to be stranger, more beautiful, and more terrifying than anyone could have imagined. When the telescope was first designed in the 1970s, at that time, astronomers hoped to find several dozen black holes. Chandra found thousands. They hoped to understand how these objects grow. Chandra has shown that they grow in ways that contradict all theories. They thought that black holes were the end point of evolution. Chandra proved that they're the starting point, the seeds from which galaxies grow. One of Chandra's most surprising discoveries has to do with what astronomers call the feedback effect. It turned out that black holes don't just passively consume matter. They actively regulate their own diet. When a black hole starts devouring too much too quickly, the energy released is so powerful that it repels the surrounding gas, cutting off the flow of power. A black hole starves itself. Then, as the radiation weakens, the gas can approach again, and the cycle repeats. Chandra observed these cycles in real time in dozens of galaxies. In some cases, periods of activity and rest alternate every few million years with amazing regularity, like a cosmic clock. In the galaxy NGC 5813, the telescope found a series of concentric rings in the hot gas, traces of periodic energy emissions that occurred every 50 million years over the past 300 million years. A black hole breathes, inhaling matter and exhaling energy with metronomic precision. This discovery turned the idea of the growth of black holes upside down. They do not grow smoothly and constantly. They grow in impulses, jumps, going through periods of gluttony and starvation. Our own black hole, Sagittarius A-, is now in a period of near total starvation. It consumes matter at a rate equivalent to 1 Earth per billion years. For comparison, during periods of activity, black holes could devour the mass of thousands of Earths every day. But Chandra's footprints around Sagittarius A suggest that just a few hundred years ago, our black hole was much more active. What made her fall silent? Scientists don't know. Maybe she just ate everything available nearby. Maybe a supernova explosion, the passage of a star, disrupted the gas flows that fed it. Or maybe it's just part of a cycle, and in a few thousand years she'll wake up again. If this happens while humanity still exists, we will witness an incredible spectacle. The center of the Milky Way will shine in X-rays. From Earth, of course, we won't see X-rays. Our atmosphere blocks it. But radio telescopes and orbiting observatories will record a dramatic increase in activity. Sagittarius A will turn from a quiet shadow into a roaring monster. Should we be afraid of this? Chandra helps answer this question. Observations show that even during periods of maximum activity, central galaxy black holes are dangerous only to objects in the immediate vicinity, within a few light years. We are 26,000 light years away from Sagittarius A-. At such a distance, even the most powerful flare will not be more dangerous for us than a flare on the sun. The radiation will weaken, dissipate, and be absorbed by interstellar gas long before it reaches the solar system. A black hole at the center of our galaxy is not a threat. This is our anchor, the gravitational center around which all the 200 to 400 billion stars of the Milky Way revolve. Without it, our galaxy would have had a completely different shape, perhaps would not exist at all as we know it. Among all of Chandra's data, there is an observation that makes one wonder about the very nature of time. In 2016, the telescope detected X-rays from a quasar so far away that it took 13.1 billion years for the light to travel to us. When this light began its journey, the universe was only 690 million years old, 5% of its current age. Think about it. The photons that hit the Chandra detectors were emitted by matter falling into the black hole when the universe was an infant. These photons traveled through the cosmic void for 13 billion years, a time 3 times the age of Earth. During this time, they crossed expanding space, passed by forming galaxies, and witnessed the birth and death of countless stars. Finally, in July 2016, they reached the mirror of a telescope orbiting a young planet in a provincial galaxy and were swallowed up by a silicon detector created by intelligent beings. These photons carried information from an era when there were no heavy elements in the universe. There was no carbon, oxygen, iron in appreciable quantities. The first stars had just begun to produce these elements in their cores. The black hole that emitted these photons was formed from almost primordial matter, hydrogen and helium left over from the Big Bang, and now beings composed of elements that did not exist then are studying it. We're looking to the past. Each observation of Chandra is a time machine. The farther we look, the farther back in time we look. And the strangest thing is that we cannot see the future of these objects. The black hole we observe as it was 13 billion years ago may be very different now. It could be 10 times more massive. It may be inactive. Her galaxy could collide with another galaxy. Or theoretically, though incredibly unlikely, it may not exist at all. But we'll never know. Information about what is happening to this black hole now will travel to us for another 13 billion years. And when it reaches Earth, our civilization will almost certainly no longer exist. Perhaps there will be no Earth itself. The sun will become a red giant by that time and will swallow the inner planets. This is a cruel limitation of cosmology. We study the past, but we will never know the future of the objects we observe. We see ghosts of what was, but we cannot know what is. And yet, that's where the beauty of Chandra's work lies. He shows us the history of a universe recorded in light. Each X-ray observation is a page from the cosmic record, an account of the events that shape the structure of the reality in which we live. In 2020, Chandra discovered something that forced astronomers to reconsider the time frame for the formation of black holes. In a galaxy that existed when the universe was only 470 million years old, the telescope detected an active supermassive black hole. It was absurd. According to all calculations, in order to grow to such a size, a black hole needs billions of years of constant power at the limit of its capabilities. But here it is, it exists when, according to all the rules, it should not exist. It's like finding a 100-meter tall mature sequoia tree on an area where the forest was planted just 5 years ago. Physically impossible, and yet it is real. This discovery gave rise to new theories. Could it be that the first black holes formed not from stars, but directly from the collapse of giant clouds of gas? Could it be that there were mechanisms of ultra-fast growth in the early universe that we don't yet understand? Or, more radically, are some black holes primordial black holes that formed in the first moments after the Big Bang? Chandra does not give definitive answers to these questions. It provides data, facts, observations. An interpretation is the work of the human mind. And it is in this interaction between machine and intelligence, between observation and theory, that scientific understanding is born. For a quarter of a century of hunting, Chandra turned black holes from mathematical abstraction into living objects with their own stories, characters, destinies. Some are quiet and peaceful, dormant for billions of years. Others are fierce and active, devouring everything around them, with a veracity that illuminates half of the universe. There are old black holes starving to death in empty galaxies. There are young people who have just woken up to their destructive power. There are exiles wandering in the void. There are couples circling in a death dance before the inevitable fusion. And Chandra addresses all this like a silent guardian, collecting photons that carry stories from the depths of space and time. Someday, perhaps very soon, his systems will finally fail. The gyroscopes that keep the telescope pointed at the target will wear out. Detectors are radiated by cosmic rays for decades will lose sensitivity. Solar panels degrade so much that they will no longer provide energy to onboard computers. And Chandra will fall silent, turning into another piece of space debris in orbit around the Earth. But his legacy will live on. The archives store terabytes of data that scientists have not yet had time to fully analyze. Every year, new research is published based on Chandra's observations made years and even decades ago. Future generations of astronomers will return to this data, find in it what we missed, make discoveries that we did not even think about. And perhaps Chandra's most important legacy is changing our understanding of our own place in the universe. We thought we lived in a galaxy among galaxies in a space full of stars. But Chandra showed us that we actually live in a universe of black holes. They're everywhere, at the center of every major galaxy. They're scattered throughout space, invisible but omnipresent. They form the structure of the cosmos on the largest scales. They determine the fate of galaxies. They're the hidden architects of the reality we see when we look up at the night sky. We are the children of the stars, as Carl Sagan like to say. Every atom in our bodies has been forged in the nuclear furnaces of stars. But now we know more. We're the children of galaxies formed by black holes. Without them, our Milky Way would have a different shape. The sun would have been born elsewhere, or it would not have been born at all. The Earth would not exist. We would not exist. Black holes are not just cosmic monsters that devour light. They are a necessary part of the cosmic ecosystem, as important to the formation of galaxies as predators are to the health of the Earth's ecosystem. They regulate, control, shape. Yes, they destroy. But destruction is also an act of creation, clearing space for the new, transforming the old into building material for the future. Chandra's hunt for black holes is actually a hunt for understanding, for answers to questions that humanity has been asking for thousands of years. How did the universe originate? How does it evolve? What is our role in it? And perhaps the most important question is whether we are alone. Because if black holes form galaxies, and galaxies contain billions of stars with planets, and if life originated on one of those planets, our own, then why can't it arise elsewhere? How many civilizations are at this very moment looking through their telescopes at the centers of their galaxies, observing the same black holes, asking the same questions? Chandra can't answer that. His eyes see only X-rays, only hot gas and dying matter. But each of his discoveries adds a piece to the vast mosaic of our understanding of the cosmos. And someday, perhaps, this mosaic will be complete enough for us to see the whole picture. In the meantime, the hunt continues. Every night, while you live your life, love, dream, rejoice, and sad, a telescope named after the great scientist rotates high above the atmosphere. He looks into the abyss. He hunts down invisible monsters. It records the stories of crimes committed billions of years ago in galaxies so far away that the light from them is only now reaching our eyes. And these stories tell us the universe is stranger, more beautiful, and more terrifying than we ever imagined. Darkness beats in her heart, but it is this darkness that has created the light in which we live. It was the monsters that devoured the stars that allowed these stars to be born. It was the predators hunting in the cosmic night that formed the conditions for the emergence of life, intelligence, and the ability to ask questions about the nature of reality. We hunt for black holes, but perhaps, in a sense, they were after us, creating a universe in which beings capable of understanding them could appear. Thank you for being with us on the QUASARIA channel. Look up at the sky. There, in the darkness between the stars, there are secrets that we are only beginning to uncover. And each of these mysteries makes us a little wiser, a little humbler, a little more fascinated by the improbability that we exist in this strange, majestic, infinitely complex cosmos. See you on your next journey through the universe.